Bom dia, pessoal. Bom, não sei se vocês já leram um bocadinho, presumo que estão todos aqui, eu diria que sim. Já leram algumas coisas sobre microservices e provavelmente leram muitas das coisas sobre porque é que microservices são a nova coisa que toda a gente quer usar e que toda a gente quer perder tempo e mesmo quando não precisa vão usar na mesma. Basicamente a ideia da minha talk é espelhar um bocadinho algumas das experiências que eu já tive e infelizmente nem todas foram assim tão boas como eu gostaria. Basicamente eu vou começar por fazer um bocadinho a ponte entre microserviços e SOA, porque apesar de muita gente dizer que SOA não presta, na realidade microserviços são feitos usando os paradigmas do SOA, adicionando mais algumas questões ou sobretudo fazendo enforcement de alguns pontos que antigamente no SOA não se tomava tanta atenção a isso. Depois vou-vos falar um pouco sobre API Design e porque é que isto é tão importante quando estamos a trabalhar com microserviços. Na realidade não era bem isto que eu queria dizer, mas tudo bem. Bom, isto é um bocadinho do meu background, do que é que eu tenho andado a fazer e a trabalhar. Agora não é muito relevante, se alguém quiser falar sobre algum destes temas, depois pode falar, vir ter comigo. Isto são algumas das comunidades que eu, de alguma forma, tenho estado a trabalhar. Eu criei um projeto que é o Micro Toolkit, para fazer microserviços com base em ZeroMQ. Tem sido já utilizado em pelo menos 4 projetos. Tenho estado também, de alguma forma, envolvido com a comunidade ZeroMQ. Trabalhei durante algum tempo a desenvolver aplicações isomórficas com render e já fiz alguns talks também na RequireLX. A nível de agendas, eu estava a falar um pouco, portanto, o paradigma entre SOA e microserviços, falar um pouco da API Design e contratos e porque é que eles são tão importantes neste paradigma. Automação, isto é provavelmente uma das coisas que muitas das pessoas acabam por desleixar-se um pouco quando começam a trabalhar em microserviços e mais tarde ou mais cedo isto vai criar problemas bastante graves. Integração, isto é outro dos problemas que eu também tenho apanhado. By the way, English speakers here? You are, okay. Sorry about that, yeah. I forgot that. Sorry, man. I forgot that I mentioned that the talk would be in English. Okay, so if you don't mind, guys, I'm going to switch. Sorry. Talking about integration patterns and some problems that I found out when people are developing microservices and don't think really well on this, or usually it's because it's easier to do another path and they will go through it and then we'll find the problems later on. And the other part is about monitoring and logging, and this is probably the biggest nightmare that you can have in production, because you need to find where the problems are, you need to find them fast, and when they exist, if you don't have the tools, then you are just screwed. Okay? So the first part is, let's compare SOA and microservices. So basically, SOA was about creating boundaries, about business, creating autonomy for teams, defining contracts and schema to be reusable across the entire systems. The real world was entirely different from what everyone was talking about. You start to see giant ESB with superpowers that know much more from the business that sometimes the actual service implementations knew. So we started to have a place where everything could fail and no one knows why, even the owners from the service most of the time. The other part is that you started to have a centralized governance. What do I mean by that? Usually these kind of decisions are not made by the team. They are made by someone in the company, usually by the bosses, and most of the times even related with commercial interests on it. So this, for me, it's basically where it was the biggest problems in there. The other part was about technology coupling. With these ESB parts, sometimes you started to see a lot of things that not all technologies have support for it, like all the WS standards that nowadays most of the company or most of the language don't even bother to support it because they are basically not used in most of the cases. On the other part, we have a lot of benefits from using microservices. So basically, we started to define boundaries again as the same part. We also talked about contracts and autonomy. In the contract parts, there is already a few changes or key points that make a lot of differences. Basically, starting to define loose contracts. So in the past, we would use, like most of the time, SOAP and schemas that would be really strict on what you have. And once you update your contract just by adding a property, most of the times the consumers would break, and that means that you have to align the entire world until you actually do a deploy to production. That doesn't work in the microservice world. So the approach that most people talk about, and it makes sense, is that you need to expect that your contracts are loose. By doing that, it means that if I add properties into my contract, doesn't mean that the consumer should break. No, they should be able to handle with that. On the other hand, if I remove them, okay, then I'm breaking a contract, okay? The other part is about fine-grained scopes. So you could actually build in the old environments with SOA, you could actually build your services smaller, but that wasn't what, in practice, what was happening. Most of the times, the service were probably a catalog with 300 operations in it that several times you don't even understand what they do because they are really similar. In this case, what microservices talk about is doing things in a more smaller grain. That is, you need to be really careful with this decision as well. Okay, I will be talking about it later on as well. So in the other part, process automation. I need to be able to just merge a pull request, ensure that it's working, ensure that I don't break my consumers, and after a couple of minutes will be deployed into production in a way that no human need to interact on it. This doesn't work always like that, and if you guys actually work with real applications, you also know that when you are using external systems from big enterprise and so on, sometimes you need to find some consensus and find some middle ground where you can actually do this, but this is the optimal goal. You do your development, you ensure that it works, and then it goes directly to production. This gives us much more speed, delivering products and even bug fixings and so on. The other part is technology agnostic. This is really important in the fact that I have two teams in my company. If they both want to use different technology, doesn't matter. It's not up to me. Different problems can be solved with different technologies that do better than others in certain cases, okay? This was something that with the old approach would also fail. Nowadays, most people use REST and the HTTP that every language that is, we can call language, will support on it. Using that, we also might have a few problems in there. We go on that first, later on. So going from there, so light message protocols like HTTP, if we can call it light that way, but yeah, still lighter than the past ones. The other part is decentralized governance, as I speak, in the past. So basically, everyone can choose whatever tools they want, and they are able to integrate to the others. And basically, it's team's decision to go further. And if you have someone working with the skill set that they want to work, you also have more productive teams because they are enjoying what they do instead of actually fighting against tools that they basically hate. The other part goes into the ESB part. So ESBs can be actually a really good thing. Okay? They are useful. They have their place in any architecture. But the problem is the way we do it. Okay? If you use any broker, enterprise service bus, whatever, as a dump pipe and keep our endpoints smart, then does it mean that they are just a piece in the middle of your layer? Okay? You don't put any logic in there. So in the real world, actually this started for, I would say, 3 real implementations for 3-4 years. And what I say is only God knows yet, because in 5 years we'll know what actually happened with those architectures and how they evolve. Okay? As I talked, I would say that we are in a good path, but I also have seen things that are even worse than actually creating a monolith to develop and maintain. Okay? going to what is for me the most important thing in every SOA or any service architecture. Doesn't matter if it's a microservice or not. It's about contracts, okay? I think the way you define contracts is probably one of the pieces that you should spend more time on it. The reason for that is that they are really hard to do it right. And they are even harder to do it right at first. So going from there, what I see is that you need to try to see loose coupling between the microservice. You need to create data contracts and operation contracts that are actually exposing your business capabilities and your domain models in your organization. So the first part is you need to actually know what is your organization about, what is your business, in order to start doing a microservice. If you are doing from scratch, let's say, a new product that you don't even know what's going to end in there, you probably shouldn't start in that way. You can, of course you can, but I think you're probably going to have more headaches and you're going to have good results from it. So from there, organizing your services around the business capabilities and your domain models. And two really important goals is that once you have a model that is a customer related with, let's say, inventory probably needs a completely different set of data than a customer for, let's say, alerts or something like that, okay? So basically, you need to identify between those services, between the domains, between the business logic that you have in there, you need to identify where are the common grounds on it. And within there, doesn't mean that you need to expose everything to everyone, okay? The way you should do it is keep it as lean as possible, clean, so any service should know the minimal information that they need to know in order to do their job, okay? Within that is what we call as shared models and not implementation as well. So basically you share contracts with part of your information doesn't mean to be anything, everything, and much less even exposing everything that you have in your system, okay? The other part about sharing the models and not an implementation as well is that once you do that, you are not attaching any consumer to what you currently have in your system. You are attaching your consumer to your operations and business capabilities that they offer on that point in time, okay? So the other part is about the hidden models. You have several different microservices can have different models that no one needs to see, only them, okay? So if you have them, until you have a really good reason to show them to the world, so just keep it hidden and don't do it. Because once you put it public, you need to support it. Once you need to support it is one more thing that you need to deal with. Breaking consumers, doing versioning, and so on. So for me, this is probably the most important goal in a microservice system. The other part that I was talking about contracts is basically you need to have a big picture first, of course, but you need to be agile and you need to go and start doing your stuff. True. But if you want to be agile and you want to prepare yourself, don't stick everything into the letter, try to understand what is your goal. Of course, everything can change and you need to deal with it. It's what we do in our day-to-day on work, of course. The other part is breaking down on domains, and by doing that, it's really easy to actually follow into a place where you have a giant amount of service, and basically most of them will be anemic. By anemic service, I mean a service that doesn't offer anything besides storing data and retrieving it. Because you don't have, a good example on that is reference data that you probably use to just list in some front end or something like that, but you don't have any business logic behind it, okay? This is a little bit tricky, and there is a couple of approaches that you can do by this. You can create an anemic service and you probably start to see a lot of mushrooms appearing in your architectural place, or you can keep this kind of service in a monolith until you actually have good reasons to start splitting it, because it's actually really complex to start dealing with it, okay? The other part is about breaking consumers. So if you build a microservice, it means that someone needs it, okay? probably several entities in your company will need it, and some of them will rely on different operations, different perspectives on your microservice. What is really, really hard is actually when you are building distributed systems, is testing if everything works end-to-end, okay? If you want to actually deploy fast, doing end-to-end tests across all your systems, it's really, really complex. It takes time, it takes a lot of effort, and so on. One way that you have to ensure that you are not breaking consumers is by doing what we call as a contract-driven test. So basically what you are doing is ensuring that a certain consumer is dealing with your service in a certain way, and every time that you deploy a new version, you test it that way. And this needs to be done in both sides. So your pipeline needs to handle, not only understand that a new version of your dependency is actually being triggered, and by doing that, he also will run their tests and ensure that it's still working the way it should. This is complex, and this is something that I haven't seen being done that often, but it's really important, because if you don't do this, it means that it's really easy for someone to break your contract and just don't do a mistake and don't understand it, and then you'll have your boss shouting out at 3 a.m. telling you, okay, you broke everything, I'm losing tons of money, so please go there and fix it, okay? Automation, so this is the other key point. So basically, if you want to start building your own mushroom farm, it means that you need to be able to handle with the way all your different parts are in there. So you need to be taking care of a few considerations. You need to deliver it fast. You need to create independent deploys. And to do independent deploys, it means that your contracts need to be really well defined. And you need to be aware that every time that you are changing the contracts, you need to be aware if you are breaking them. Because if you are breaking them, you need to be handling with versionings. If you aren't, then you are screwed, because you need to deploy several microservices in a place. And basically, this is what we call as distributed monolith. That is even a biggest nightmare than having a monolith by itself. So having an automated deploy pipeline with all these steps that I talked about, doing the tests, doing consumer-driven tests, and so on, it's also really important too. The other part, everyone knows automated tests. If you don't know that, probably you shouldn't be in this conference at all. So I would say that I will skip that one. Automated provisioning, this is also important, and because if your business grows, your systems need to grow with it. And by doing that, you also need to be really fast putting your systems up and running. So putting any system from scratch up and running is difficult. If you do it by hand, you will probably have some hard time to replicate it. If you do it using proper tools, you will see that it's really easy to just scale, because you have too many requests per minute, and you just start scaling your farm on it, okay? So the key point is automate everything. Even if you want, automate the simple tasks that you do on nowadays just to create a new endpoint. But automate the way you deploy, the way you provision your machines. It's really important for this. Integration. That is probably where I see most systems failing on, okay? There is several ways to integrate. There is several patterns. There are a few patterns that I've been seeing being applied for several reasons, and some of them I even have made them. And after a couple of weeks, months probably, I start to see that wasn't a good decision. So what I'm trying to say here is not microservice might be a good solution, but might not be the solution that you need. And sometimes we do decisions that are made with pressure because we need to deploy the things, we need to actually deliver. And sometimes small decisions can take you a lot of time in the future, while if you take them in the upfront, you will probably not have that kind of headaches, okay? So design and service usability is really important. If you have an API that basically no one understands, that doesn't have any documentation, that sometimes even not your team knows how it works. Basically, if you are doing that bad, then probably should start considering dropping microservice, go to a monolith, or start considering improving that. So any microservice need to have documentation. You need to know how to deal with it. Your consumers need to know how to face it. So the other part is also about the design. It needs to be easy to understand it. If it's hard, if it's complex, and sometimes, depending on your business requirements, might be tricky to understand what you need to do in order to do that. So it's really important. Breaking changes. I've seen this in past, several companies starting to go, even for an API, doesn't matter if it's a microservice or not, starting just deliver it, and then they have 3 or 4 different consumers on it, and they understood that they need to actually create versions. Why? Because the business changes and we need to continue with it. And if you don't think about this upfront, then on that point in time, you will end up maintaining 2 different systems. If you go into that path, you have some patterns that you can use to keep reusing or keep the old contracts working, but consuming from the new ones. This is not always possible, but it might be a solution, but it takes a lot of time until you actually put everything working. If you think about versioning up front, then you are able to produce the results faster. Okay? By doing this, keep one thing in mind. Your business will change, so with that, you'll break this thing. So start by first part is how you're going to deal with breaking changes, how you're going to deal with this evolution of the service. The other part is also about integrations. So a lot of people that I've seen use HTTP requests to build microservice. I'm not saying that is wrong, okay? Depending on what you are doing. But what I have seen in practice is that a lot of times you start having consumers and systems that will probably consume for a single API request, probably doing 15 or 20 requests to other service. Doesn't matter if it's in parallel, if it's SQL, doesn't matter. What I mean is that if you are starting doing that, this is also what I caught as starting to be a nightmare, okay? So in that pattern, I would say that you should start considering from scratch looking into event-based systems, because that way you can actually decouple the services more easily. It's more complex to maintain, but it's more easily to evolve and much more easily to keep your consistency and reliability on your system and avoiding cascading failures. Because if you have chatty services, it means that they will probably not have all the domain models that they need in order to do their job. It also means that they need to call other systems to do, let's retrieve data for a certain action. If that's other services also down, it means that probably it starts to react as chain reaction. It starts doing a chain reaction. That means that probably your system will be down or partially down because of that. Once you start to having an event-driven system, you'll easily be able to keep shadow copies on this and probably work in, I would say, 80% of the case, do what you need to do without relying on that, okay? But keep in mind, this is also a little bit more difficult to maintain. It also contains another set of problems that you probably wouldn't have by just using request and reply. The other part goes into design for failures. It's also really important in the case that I was talking about. So basically, if one service is down, you need to understand how you're going to deal in your service when you don't have the data that you need. So basically, you are building distributed systems. So the network can fail and will fail, okay? More often than we sometimes think. So we need to be able to react and to understand how our data and our business should react on that. Sometimes we can proceed with it. We can later on try to react and do some other actions to compensate that. But we need to understand how we should approach that kind of scenarios, because they will happen. One good example on this is probably a lot of you guys already heard about, is Chaos Monkey from Netflix. They basically start disconnecting machines, start disconnecting service, and they start to see how the system reacts on it. And basically this is a little bit insane, true, but gives you the confidence when systems start failing, because it will still keep your business working on. But this is a little bit tricky also, okay? The other part, technology agnostic. And from there I'm going to the database part. It's not the first time that I've seen systems built on microservice that actually share the database models. I've been done that, okay? So I'm one of the persons. The reason why I did that was actually because I needed to deliver stuff, and we already started on that. And basically, if you create new database, once you don't have automation, backups, and everything in place, it means that you have to start doing it. So your requirements to build a new service will be bigger than the one just adding functionality to the monolith that you have. So I just needed to deliver. I did it. A couple of weeks later, I started to have a lot of nightmares and problems with that, and we have to start decoupling everything. So on that, basically sharing your database model, it means that you cannot evolve your systems based in your needs. You need to start coordinating systems deploys and so on, and you are basically breaking all the concepts and all the good things from actually using microservice. The other part, this is a little bit a pattern that I've seen in not only microservice but APIs as well, is that a lot of companies start creating client libraries. That's a good thing. It's not a bad thing. The problem is that when your client libraries start to actually get coupled with your service implementation. By that way, it means that any consumer will not work unless they use your client libraries, because otherwise your business part is in there and they also have to implement it, and if you change it, they also have to do it. You are screwed. So if you go that pattern or into that kind of features, be aware that your client libraries should not be attached or coupled from your contract. So one good way to ensure it is that you have a different set of teams actually building that part, because that way they all probably not going to take the easy steps just to get something delivered on, okay? We need to consider that every time we are developing software, we are developing it with people. And people tend to do some decisions that are not always the best, okay? So having more than one and decentralized decision on these kind of points also helps you a lot. The other part, monitoring and logging. I'm not sure how many of you guys have microservices in production. Anyone? You have? Okay. How many production problems you have in? Yeah? Okay. One of the biggest nightmares that you can have is basically your system start failing and you don't know why. No, it's not mine. And you don't know why, and you need to find it really fast. So let's say if you only work for Europe, you probably have one server here, some few in Amsterdam or something like that, and probably you have, let's say, a fleet with 10 microservices. It means that your logs are across a boundary of not only forms, but also a boundary of services. It means that you need to identify each calls that are made through each of them and to relate with the actual initial call to understand what is the problem. Once you start having these problems in production, if you didn't prepare yourself for this in upfront, it will be really, really difficult to understand what is the reason for it. Even more once you have more people on your website, and basically you don't know if it's scalability, you don't know if it's a system problem, if you don't know if sometimes even if it's a business feature that wasn't completely correct, something like that. So centralizing your logging information is probably one of the most important things that you need to have in a microservice systems. So by centralizing them, doesn't mean that only centralizing will solve the problem. No. You need to be able to understand what is being logged and why. And you need to be able to understand your chain of requests and the chain of events in order to reproduce it and try to understand and follow the problems. So by doing that, one thing that a lot of people already did that in the past, even using SOA and brokers, the things that we hate sometimes. It's by using correlation identifiers. So basically, if you pass an identifier to all your calls within your network, it means at least if you are logging any decent information with it, you are at least can keep the track on it, okay? By doing that, there is also some really nice tools that are appearing that allow you to identify problems like performance issues that you have, or because a service is too chatty, is actually stressing the entire system because it's doing a lot of more requests than it should, not using, let's say, bulk operations and things like that. If you have this kind of real-time dashboards that allow you to know the amount of requests that are flowing in there, the time responses that each service have, even in a certain request, what was the time that it lost in those kind of steps. Let's finish. Even understanding the amount of time that each request took in an entire chain, then you are able to react and to understand what is the actual problem. So dependency graphs are really useful, especially for not only understand where are the consumers, where are your dependencies and so on, but also to understand what is the performance gaps that you have on them, okay? Any more questions? You said that you wanted to talk about something. Any micro? No. You have to speak louder. Yeah. Do you have any micro in there? Okay.
First of all, congratulations for this presentation. It was...
Okay. It's connected? Yeah, it's not working.
Congratulations. It was one of the best presentations I saw about microservice here. My question
Thanks.
is, you started working, I see that you actually implemented something in production.
Yeah.
My question is, when did you start? 2 years ago? 2, 3?
When I started?
Yeah, when did you start
using microservice?
Yeah.
Okay, I started doing microservice or SOA in a microservice way, let's call it like that. I would say 7 years ago, okay?
Okay.
Because I started to decouple my service in small,
sure.
fine-grained services. With it comes a lot of problems like not having transactions that they are really useful and things like that. More recently, I started to shift and living SOA about 4 years ago. And basically I built, it's currently the third system that I'm building with microservices. 2 of them is using the library that I built with ZeroMQ on it. And I'm going to the third one, basically designing a new architecture for an existing system that is also another challenge.
Okay. I usually ask this because microservice got trendy because of technologies like Docker coming alive. And I wanted to ask you because did you use Docker for all the continuous? No. Yeah, 7 years. Answer that.
Even the last ones, I don't. And the reason why I don't do it is that the way I think is that you need to keep your technology stack as simple as you can. Okay. And sometimes you need to make decisions. Docker is really awesome. It is. But you need to understand where are you putting it to work. Sure. So you need to have your team prepared. Sorry, guys. You need to have your team prepared to work with the tools that you have. So sometimes you need to make decisions in order to see if it fits in your company, on your organization, and in your team as well. Okay? So, and microservice is probably one of the things that you need to understand. This is not only about developing. It's about maintaining. It's about DevOps. It's about infrastructure. So you need to be aware of that kind of stuff.
Okay. One more question. You're saying that everyone should go, like the option should be using event-driven design,
systems, yeah.
Event-driven systems, or you call it.
Yeah.
But the problem is in a request that you are doing both or only one? Because there are some requests that you really need to do request reply. And
so basically,
how did you solve that issue?
Yeah, the goal and the way I see it fits most of the time is not by only using only one single pattern, okay?
Yeah.
Is by using request and reply, most likely for APIs and for external consumers, and using event-driven systems to communicate across your network. Because basically, by using events, you are able to continue keep your copy from your data. You can
and you also have
events.
failover.
Exactly,
yeah.
but you also make it easy to consume for your consumers when it's request reply. It's not always possible, because sometimes you might have long-running processes, and in that case, probably event or asynchronous communication is better than actually a request reply pattern.
Okay.
Does it reply to your answer?
Yeah. I just want to know if you were using both.
Yes, I'm using both.
I think that's the only option.
Okay. Yeah.
Okay. Thank you.
Yeah. More questions, guys? Yeah. Yeah.
Thank you. Do you use an existing tool for tracing?
Do I use?
Any existing tool for tracing? Like there is Zipkin.
Exactly. That was the tool. Okay, about you were talking about tracing and so on. Yeah. So what I was talking about tracing later on, and to be able to understand what the flow goes, one of the tools that I'm not using currently in production. Okay, what I'm currently using basically is Kibana or Splunk, and with Elasticsearch, LK-Stack, something like that, that allows me to see the flows and so on. But one of the tools that I'm looking about 6 months, starting to look into to use in the stack as well was Zipkin. Zipkin basically, the way it works is that from the beginning you instrumentate your code in a way that you start storing some event information, and your identifier is built in hierarchy. It means that they also have a front end that you are able, by using a request identifier, be able to trace down the entire request and to see where it went and also how long it takes. So yes, as far as I know, I think Zipkin is the only tool that at the moment is actually production reliable, but also really useful for that kind of pattern. I don't know what others might have, but I think most of them were started but never went really far from there.
But is your experience good with it?
I started to use a little bit, but I'm not using it in production yet. One of the reasons because they mostly were supporting Cassandra. Currently they have started other implementations with our data stores, and since we don't have Cassandra in the company, I don't want to introduce that just because of this reason.
But between microservices, it can be useful already, right?
Yes, really useful. I think that's basically one of the tools that you should consider using something like that to be able. At least if you have LK-Stack or Elasticsearch, Kibana, and Logstash, you are able to at least centralize your logs, have dashboards with real-time things. It's probably not as complex as Zipkin is, because you have a little bit complexity putting, not including it in your system, but the system itself, it's a little bit more moving parts, let's say that, okay? But with LK, at least you are able to see the traces from there and so on. And that's what I'm currently using in my projects. Okay? More questions, guys? You can talk.
Hi.
Hey.
What kind of workarounds you have to handle calls to multiple services?
I'm not understanding.
What kind of workarounds you have to call multiple services and have kind of transactions between them?
You don't have transactions in microservices.
Yeah, I know.
And that's basically answering to your questions. Most of the systems, what they would do, even long time ago, we had AWS transactions, but I haven't seen that many services actually using it. So what most of the systems and the way you actually solve that kind of stuff is basically by, one, you hope it works several times, but when it fails, you usually keep a log of the things that fails, and you need to have tools in order to keep going on them. Depending on your business, might be a bigger or smaller problem. Another solution for that is basically, if it's even instructing your system, that is really hard to do for all scenarios, is to be able to recover and undo all the changes that it did. So depending on your requirements, you might need to be using one solution, the other one You might even find out some other kind of transaction mechanisms that you can. But by doing that, it means that also you are adding more complexity into your system. So you need to consider really well when and where do you actually need it. Okay. So yeah, does it reply to your answer? Yeah. More questions, guys? No? So I think we are done.